Hello, AP Chemistry students, and welcome to your AP Summer Homework, Unit 2, Lesson 2, which is all about the mole. So before we go into mole conversions, and that's where this unit and lesson is headed, let's first talk about dimensional analysis and what it is. Remember, dimensional analysis is a method by which chemists keep track of units of numbers during mathematical operations. So every number in chemistry has two parts: a numerical value, and also a corresponding unit. And we set it up so that units can cancel when we understand and use dimensional analysis to convert between things and amounts and understand math problems. So always you're going to be given something. This is a one-step problem on the bottom, so you're only going to have one of the equals amount sections. So you always go with your starting amount. Your equal amount is going to be that conversion factor, that ratio, that constant that you know. So in this case, we know that 1 foot has 12 inches in it. And then you're going to arrange it so that you started off with inches. You want inches to cancel. That's why 1 foot's going to be on the top and 12 inches is going to be on the bottom. So when we type this into the calculator, remember that we do 24 times 1 divided by 12, and that's going to give us 2. And that's how we know that in 24 inches there are 2 feet. We do these in our heads, but with our chemistry numbers that we're going to be using this year, we're going to have really large and really small numbers, and we're going to be converting from multiple things, so our problems are going to get larger. So using dimensional analysis will help us keep it straight. So that's your dimensional analysis review. So now let's talk about mole conversions. Mole conversions are going to be very helpful to us. Moles allow for us to convert between multiple things. In most cases, if you are not given moles and you need to get to moles, or you're given moles and asked to get to mass, you're going to need the molar mass, and that's going to be what your equal amount is, or your equivalent amount. So we know that 1 mole is equal to a molar mass of either an element or a compound. So that can be written as either 1 mole over the molar mass of an element or a compound, or the molar mass of an element or a compound over 1 mole. So let's look at an example problem. This is going from mass to moles. So the question is calculating, Hello, AP Chemistry students, and welcome back to your Unit 2 AP Summer Work, which is all about stoichiometry. Let's talk about Lesson 2, which is moles. So before we talk about moles, let's remember what dimensional analysis is. Dimensional analysis is a method by which chemists keep track of units of numbers during mathematical operations. We do a lot of math in chemistry. Dimensional analysis allows for us to not use equations per se, and we can just convert based on units and conversion factors, equal amounts, things that we know that are always true and never going to change. So remember, all measurements in chemistry have 2 parts. The first part is a numerical value, a number, and the second part is the corresponding unit. So when we look at this example down here, you're always going to get a starting amount. Any problem that I give you, you're always going to get whatever that starting amount is. So that gets written down first. The bars allow for us to separate what we need to separate out. In that middle section is where we put our equal amounts. That's where your conversion factor is going to go. We know, common knowledge, that in 1 foot there's 12 inches. It's arranged with 1 foot on the top and 12 inches on the bottom because we want those inches to cancel, as you can see that they do. So now remember, when you type these things into the calculator, you always multiply by what's in the numerator and divide by what's in the denominator. So when we multiply this into our calculator, we're going to put 24 times 1 divided by 12, and that's how we get the 2. And then since inches cancels, our ending unit would be feet or foot if it was singular. Now let's talk about mole conversions. In mole conversions, you're going to use the molar mass as your equal amount. So 1 mole is going to be equal to the molar mass of either an element or a compound. and it can either be written as 1 mole over the molar mass of the element or the compound, or the molar mass of the element or compound over 1 mole. It depends on what do you need to cancel. Do you need the mole part to cancel? Then if so, it's going to go like the second example on the bottom. If you want the mass to cancel, then it's going to be arranged like it is in the first one. So the easiest way for me to explain for you how to do this should be a review, is we're going to do 2 quick examples and then you're going to have some questions to answer. So let's look at example 1 together. You're going from moles to mass. The question reads, calculate the mass of 6.70 moles of carbon. You need to know that 1 mole of carbon is equal to 12.011 grams of carbon. Where did I get that 12.011 grams? That is the molar mass of element carbon that is on the periodic table. So we're going to write down what we're given, our starting amount, which is the 6.70 moles of carbon. We're then going to write up our bars so that we have a place to put everything. Then we are going to arrange that 1 mole of carbon to 12.011 grams of carbon. Since we want moles to cancel, we need to arrange it as so. So we need to put 12.011 grams of carbon on the top, 1 mole of carbon on the bottom. The moles are obviously going to cancel because just like in anything, when you have it in the numerator and then in the denominator, it cancels out. When we type this into our calculator, we're going to put 6.70 times 12.011 divided by 1, and that's going to be equal to 80.4 grams of carbon. So our answer for this problem is 80.4 grams of carbon, and that is written in the correct number of significant figures as well. Let's look at example 2. Example 2 is the opposite, going from mass to moles. The problem reads, determine the number of moles in 8.0 grams of boron. Once again, it's just an element that we're talking about, so we're going to go to our periodic table, grab the molar mass for 1 mole of boron, which is 10.81 grams of boron. So we're going to first start off by writing down what are we starting with. We're starting with 8.0 grams of boron. We're going to put up our bars for our dimensional analysis. Then how do we need to arrange the 1 mole of boron is equal to 10.81 grams of boron? We want grams to cancel because we want moles in the end. So that means that gram needs to go on the bottom. They do cancel. Now when we type this into our calculator, we're going to put 8.0 times 1 divided by 10.81. Our answer needs to be in 2 significant figures, so we're going to round it to 0.74 moles of boron.